Hi, welcome to another math problem of the week. So for today, we are going to consider a pyramid. As you can see, this is a 7 layers pyramid and it consists of 28 boxes. We are going to fill in the number inside each of the box, and the number in any box is the sum of two numbers below it. Later we will see that it is quite similar to the Pascal triangle. Okay, back to this question. We can fill in any numbers in the bottom layer. So the question asks, after you fill in all the numbers in this 28 box, is it possible for you to have the type of 15 odd numbers and 13 even numbers? Or 14 odd numbers and 14 even numbers? Or the last type, 13 odd numbers and 15 even numbers? Have a good try, and I will let you know the answer later on.
Pause the video now if you wish to solve it. Keep watching the video once ready.
After we do some trial and error, there are some interesting findings that we can see. Instead of consider numbers, we just consider odd or evens. So we can see that if this is even, this will be even. If it's even and odd, it will be odd. Odd and even, still and odd. Odd and odd, even. We are going to use a dark color to color the box containing odd numbers. There are some interesting results that you can have. For example, this is one possible outcome. So odd, even, even, even. So you can check that.
One odd, one even will give you odd. Even, odd, odd. Odd, even, odd. Even, odd, odd. Odd, even, odd. Even, and so on and so forth.
And because of symmetry, you can start from left to right or right to left. They are actually exactly the same. Not only this, after a rotation of 120 degrees, you have another parity pyramid. That is like this. And it obeys the rules that we have there. Let's say, for example, bottom layers. So odd, even, and so on and so forth. This diagram and the next diagram, they come from the same arrangement. Obviously, it can be a rotation of the other direction of 120 degrees, like this. And again, it obeys the same rules. So the first interesting result that we have is that the parity of odd numbers will remain the same. That is 3, 5, 3. They are still odd numbers of odd numbers. Here is another example. In this case, you have 2 in this layer, 4 in this layer, and 4 in another layer. Not only this, there's another interesting result, that is, again for this example, the bottom layers consist of 3 odd numbers. 3 is an odd number, and it means that the whole diagram contains of odd numbers of odd numbers. There are 13 odd numbers in the diagram. We're going to show these two results. Number one, the parity of the odd numbers in the bottom layers and the two side layers are the same. And the parity of the bottom layers and the whole figures still remain the same. We start by saying that this is A, B, C, D, E, F, and G.
Using the rules, we know that this should be A plus B, B plus C, C plus D, D plus E, E plus F, F plus G.
For this box, it should be A plus 2B plus C. But we are only concerned whether this is odd or even number. Since 2B is always even, the parity of the number after you add even number still remain the same. So we can ignore the 2B and this is A plus C. Likewise, B plus D.
The sum of the bottom
layer is equals to A plus B plus C plus D plus E plus F plus G.
The sum of the left layer.
So this is consider the left layer. We only need to consider whether it is even or odd. So we can see that there are 1, 2, 3, 4, 5, 6, 7, 7A, and it is congruent to 1A.
For B, it is 1, 2, 3. So it will be a B. For C, 1, 2, 3. And for D, it is 1. It is 1. And for E, it is equals to 1, 2, 3. F is only 1. G is only 1.
So we can see that the parity of these two layers are exactly the same. You can easily check for the other layer. You can again check that it is of the same parity. So this proves our first result. Next, we are going to see how many A's in the whole figures. Okay, so for A, there are 1, 2, 3, 4, 5, 6, 7.
B, 1, 2, 3, 4, 5, 6, 7, 8, 9. C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And for D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.
Because of symmetry, we will expect that the number here will be the same as 11, 9, and 7.
You can go and count, and in fact it is 11, 9, and 7.
And because each of these is of odd numbers, the sum of the whole figure has the same parity of the sum of the bottom layer. Then this proves our second result. Using a little bit trial and error, it is not difficult to show that all of these are possible. So this is an example for the type 1. 15 odds and 13 evens. This is the example for the second type. 14 odd and 14 evens. And lastly, this is for the third type. 13 odds and 15 evens. Beginning of the video, we mentioned that this is something related to the Pascal triangle. If you recall the Pascal triangle, this is how we construct the Pascal triangles. Each number here is a sum of the two numbers above. For this pyramid, any number is a sum of the two numbers below. For the Pascal triangle, any number is a sum of the two numbers above. And it starts with two ones at the side. And there's some interesting result if you color the numbers in Pascal triangle. So for example, if you color the odd numbers, then this is the pattern we can see. And if you make even bigger a Pascal triangle and you only color the odd numbers, we can have these nice showing pin skid triangles. The result that we have from here is only enjoyed when it is of 7 layers. When n equals to 6, the parity of the sum of the bottom layer may not be the same as the parity of the left layer or the right layer. And this is one of the examples as shown. Another interesting question that can be asked. All of this is possible, right? And this is a challenge for you. What will be the highest number of odd numbers? 16, 17, 18. Tell me your answer. Hope you enjoyed this problem, and I'll see you again next Tuesday.